Welcome friends to JCE Connect. Today course we are going to start is that is additive manufacturing 15ME 82. Myself Dr. Anand Kyosmani, Jain College of Engineering, Belagavi. Outline of the presentation: Introduction, nanoparticle synthesis, top-down approach, bottom-up approach, advantage and disadvantage of top-down, advantage and disadvantage of bottom-up mechanical grinding. Introduction to synthesis of nanomaterial. Scientists are conducting research to develop novel materials with better properties, more functionality, and lower cost than the existing one. Several physical chemical methods have been developed to enhance the performance of the nanomaterials, displaying improved properties with the aim to have better control over the particle size and distribution. It plays an important role in the fabrication and processing of nanomaterials and nanostructures and nanomaterials. Nanoparticle synthesis. Nanoparticles synthesis, in this case, the synthesis of materials takes place in top-down and bottom-up approach. In this top-down approach, you can see this bulk material, that is reduction in the size from bulk materials to powder, from powder into the nanoparticle is happening. But in case of this bottom up approach, that is a precursor containing atoms and molecules in the to clusters to nanoparticle, that is material synthesis from atomic level is happening. We'll see that is and in this we are going to have that is physical method and chemical method and biological method. In physical method, we have arc discharge method, electron beam lithography, ion implantation, mechanical grinding, milling, and etc. In chemical methods, we are going to have that is electrochemical method, pyrolysis, sol gel processes. And if you see in biological method, that is using plant and their extract, using microorganism, using enzymes and biomolecules. Top-down approach. Top-down approach start with the bulk material and cut away material to make what you want. Here you can see this is a bulk material. This bulk material is cut away into powder form into the metallic nanoparticle. In top-down approaches is a solid state processing of the material. The root is based with the bulk material and makes it smaller, thus breaking up larger particles by the use of physical process like crushing, milling, grinding. Usually this route is not suitable for preparing uniformly shaped materials, and it is very difficult to realize very small particles even with the high energy consumption. The biggest problem with the top-down approach is the imperfection of the surface structure. Imperfection would have a significant impact on physical properties and surface chemistry of nanostructure and nanomaterial. It is well known conventional top-down technique can cause important crystallographic damages to the processed pattern. Bottom-up approach. Bottom-up approach refers to build-up of material from bottom here, that is atom by atom or molecules by molecule. The root is more often used for preparing most of the nanoscale material, or that is a cluster by cluster. The root is more often used for preparing most of the nanoscale materials with ability to generate a uniform size, shape and distribution. It plays an important role in the fabrication and processing of nanostructures and nanomaterials, and you are going to have a good control over the particle size distribution, purity, quantity and quality by employing environment friendly economical processes. And this is a challenge for the researcher. The choice of synthesis technique can be key factor in determining effectiveness of the photovoltaic as a studied. There are many methods of synthesizing titanium dioxide such as hydrothermal combustion synthesis, gas phase method, microwave synthesis and Solgel processes in case of bottom-up approach. Advantage of top-down deposition for a larger substrate is possible. Chemical purification is not required. Dominant in microfabrication, well-developed technique. Disadvantage of top-down are yields broader size distribution, varied particle size and geometry, expensive technique. Advantage of bottom-up. Ultrafine nanocell, nanoparticle, nanotubes can be prepared. Deposition parameters are conducted. Nano size distribution is possible. 1 to 20 nanometer. Cheaper technique. Disadvantage of bottom-up are large scale production is difficult. Chemical purification of nanoparticle is required. Mechanical grinding. Mechanical grinding, in that you are going to have iteration. That mechanical iteration is a typical example of top-down method of synthesis of nanomaterial, where the material is prepared not by cluster assembly but by structural decomposition of coarse-grained structure. As a result of severe plastic deformation, this has become a popular method to make nanocrystalline material because of its simplicity and inexpensive equipment needed and the applicability to the essentially the synthesis of all class of materials. And the, the majority of advantage is the possibility for easy scaling up to tonnage quantities of the material for the various application. And here you are going to have that is contamination for milling media or a atmosphere to consolidate the powder product without causing the nanocrystalline micro structure. Mechanical milling achieved using high energy shaker. Here you are going to have that is high energy shaker, tumble mill, planetar milling. In this diagram you can see, and the nanoparticles are crushing in between the two balls, that is by rolling out in a ball milling. Here the energy transferred to the powder, from refractory or a steel ball depends on the rotational speed, size and number of balls. Ratio of the balls is very important in case of this ball milling or in a case of the mechanical grinding. Thank you very much for watching.